Okay, so our next job here is to add sounds to our game finally. Okay, so we've got it set up with a timer object to keep track of time. We've got it set up with a point class to kind of move and track our points. And now we're going to add sounds. So we're going to add 2 tabs actually. So this is another way we can approach adding more functions. So we're going to create a sound.h tab, and we're going to create another one called sound.cpp, just like that. Okay, and so generally the way we're going to approach this is in our sound.h tab, we're going to put kind of the main information, the way that we interact with it, and then we're going to do all the work to kind of define all our functions and stuff in the sound.cpp one. So here we're going to go if and def. Oh, you got to have the. So if not defined. And then and if. Alright, so we're going to put all of our important things here, and instead of actually doing a class, we're just going to make some functions here. Okay, we might change it to a class later though. But actually, even before that, there's something else we have to do. So with Arduino, we can use the tone function, right? If we want to generate a tone, we can use the tone function to generate a signal on a pin to create a sound. Now, what happens is that relies on one of the timers in the Arduino to control that pin, and the library that we're using for the display for the LED matrix is going to not allow, it's going to turn off all interrupts for that library whenever it's sending information to the display, just because you have to send so much information in such a short amount of time, and so we can't interrupt with it. We can't interrupt that process because it will affect the information that the display receives, and it will display the wrong thing. So the timing is really important there, and so they freeze the timer so we don't mess with it. But that means that if we were to use the tone function, it's going to make this really weird kind of crackling sound every time it sends information to the display, because we're interfering with that timer. And so we're going to actually use a special library for that exact purpose. And so there's a couple ways to do this. If you're using the Arduino IDE, like the desktop app, it's actually already included. You just have to install it. And so I'm going to show that, and then also show how to add it to the Arduino Create. So if we're on the desktop app here, let me get a fresh window. The way we would get it here is we would go to Tools, Manage Libraries, and the name of the library is called Tone AC. And now there's a couple of different ones, and so it doesn't have to be the specific one, but this is the one we're going to use. So you type in Tone AC, and then you can click Install here, but we're going to be using it on Arduino Create, which for some reason doesn't have that library included, and so you have to add it yourself. And so what we're going to do is we're going to come over to the Libraries tab. I've provided a link for it, and so you're going to go to that link and download it, and then you click Import, and then choose to import your library, and then you can just click right there, the downloaded folder, and you can upload it. Okay, now this library you can actually get it like from a different link through GitHub, but if you want to add it to here, it needs this like this properties file that isn't contained in the original library. So I went ahead and added it in so that you could upload it using my link. So anyway, we have to do that, and so once we've done that, we can then interact with it. And so the trade-off that we get from using that library is that we can only use pins 9 or 10 on the Arduino for controlling our buzzer. And so the way this library works, it actually is using pins 9 and 10. It's emitting sound on both of them, and it actually alternates them high and low. So you could connect one end of this to 9 and 10, and it's going to be really loud. And so for our purpose, you'll probably add a resistor there. Our purposes, we'll just connect one of them to pin 9 and one of them to ground. And so we'll have our speaker connected on pin 9 and then to ground. And this is for the Arduino Uno. Because we're using like a special hardware timer for this that we're connecting directly to the pin. We're limited to which ones we can use, and so for the Arduino Uno it's the 9 and the 10, but for other boards it's different pins. Okay, and so we've got that wired up, and now we'll go ahead and use it. Okay, so we're going to start with this, the sound.h file, and in here we're just going to paste in a couple lines of, and so here we have two things. So we have what we call a function prototype for play sound, and then we have this one right here that says type def enum sound state, and it's going to just have different states that represents the sound. So you have the none state for the sound, the eat, and the move state. And you'll see that I have actually assigned values. You don't, when you do an enum, you don't have to assign values, but I'm doing it here so we can use it to pull up the correct sound array that we want to use. And so this is the, basically this is the file that we interact with for this document here. So these are the only two ways that we interact with our sound kind of functions. Now in our second file here we're going to do everything else, but this is all that we use for our .ino file. And so like when you look at a header file, it's going to just have kind of the basic function prototypes, like what's available to you, and then any important type defs and things like that that you could use to interact with that those functions. And so we can actually come into here and we can say, okay, we'll make an instance of our sound state object, and so we're going to say sound state current sound equals none. Now for that to work, we need to also come up here and we need to include our sound header. So we're going to say sound.h. And then we've got our sound state here, and then when we have our loop here, we're going to read the census, we're going to take the move, and then we're going to play the sounds. Let's see, just play sound, and we've got to pass in our sound state. And so we're going to say current sound. And then, yes. Okay. And so now what we do is we're going to come down to our take move function, and anytime we make a move, we're going to say sound state equals move. And so we're going to, or current sound rather. And what that's going to allow us to do is every time we move, we're going to tell it to play this sound, and then we'll have, behind the scenes, we'll have to go and implement the code to make that work. Okay, and then we're going to come down to here, and if we were able to hit the other point, we're going to actually, instead of doing the move, we'll change it to eat. Okay, and then I think, okay, and the last thing we'll do here is we're going to say just sound, or current sound equals none. And so what we're doing here is every time through the loop we're going to play the sound, and then we're going to tell it the next sound is nothing, and so it's going to finish the sound that's playing, and then it's going to check to see what the next sound is. Okay. And so we're going to keep passing that in, and then when we have another sound ready to go, we'll pass in that new sound. And so this loop happens thousands of times per second, going over and over, and like that take move function is going to only complete this task based on our timer, and then we'll have to implement some timers in our play sound library as well, or not library, but I mean, yeah, I guess we call it library. Okay, so let's switch over to this sound.cpp file, and we'll start to put the things in here that are important. Okay, so I went ahead and pasted this in. This is not the full file, but it's just the first steps. So we've included our millis timer library so that we can use our timer object. We've included the tone AC library so that we can use that function. And then we've included the sound.h file just so we can use this type def, and then we'll have the definition for that function. So up here, let me move this over so we can see the numbers. So on lines 7 through 10, here we have for each sound that we want to play a series of notes. So the eat tone or the eat sound is going to play 2 notes, and they're going to have different delays. I just did something random here. You can change that to make it what you want, but that's our first one. And then we have our move tones, and so this is the sound that it plays when we move and how long that sound takes. And again, you can change the delays and the frequencies. And then here we have the number of sounds. I don't even know if we use this one, but currently have 2 sounds. Then we have this other array called the tones array, and it's got 2 tones in it, one for eating and one for moving. And then as we add more sounds, we can add them to this array. Okay, and then here we have the delays one, and then we have the eat delays. It's going to reference this one, and the move delays, which references that one. And then we have the corresponding lengths. So the eat sound has three notes in it, whereas the move sound has 1 note. And something that we're doing that's important here is that this is in index 0 and that's in index 1. And so here, if we were to add like another sound, say like game over or something like that, we might put that at index 2, and then we would add that to the end of our list here. We won't do that now, we'll end up doing that later though. Okay, so we'll come back and look at the rest of the stuff here. So we had those 2 arrays, the tones and the delays one, and then the corresponding lengths for the number of notes. So like, let's say I want to add another note to the tone sound, so I would go ahead and add a maybe like another one here, 300 or something, I don't know, and then give it a length of say 200 milliseconds, and then now it has length of 4, so I'd go ahead and change it here. And really the best way to do this would probably be to make a separate object for each sound, and all these could be contained there, so we don't have to organize it this way. But for now, we'll go ahead and do this. So then we have our sound state variable here, current sound, which is going to tell us what the current sound is. Our speaker, again, got to be connected to pins 9 and 10. And then we have some information here. We have a sound on state, which I think I actually got rid of. The sound length. I don't even think these are part of it anymore, so we'll come back to those if we need them. And then the num tones. I don't know if we use any of those. So anyway, these might be old variables I need to delete. We'll come back to those if they are. We make an instance of a timer that we're going to use to keep track of our timing. And then we have a state for our buzzer. So we have a type def enum buzzer state, can be in the on or off state. And then we have the variable here, and it's going to initialize to off. And so the static keyword that you're going to see a bunch of times in this file basically means that it actually, depending on how you use that keyword, it means different things. In this context, it means that these variables can only be used in this file. Okay, so this is the variable that's going to hold the array of the sound that's currently playing, and the note that's or the delays for that same sound, and then the length of that current sound. And then while we're playing that current sound, this will tell us which current note we're actually on. And then down here at the bottom we have says static void speaker control and static void switch sound, and these are functions that we're going to use to manage the speaker, but they're going to stay in this file here. That's why we've listed them as static. So like if we were in our main game file here, we couldn't call those functions because we're only going to use them from our main function, which is the play sound function. So let's go ahead and implement this play sound function. Alright, so we're going to come down to here and we'll paste this in. Okay, and now let's go ahead and put all the details in here. Okay, so first of all, I did figure out these are all extra variables here. I'm going to delete those, they're not doing anything. So we're going to come in here And this play sound function is just this. So we're going to come in here when we play the sound, we're going to check to see if the current sound is none, and there's a new sound. So we're going to check to see, basically what this does is we're going to say, the sound that we were playing before, is it done? And if it is, do we have a new sound? And if those cases are true, we're going to switch to a new sound, and we'll call this function here, which is going to initialize the new sound. And if the current sound is not equal to none, so if we do have a current sound, we're going to call the speaker control function, which controls the buzzer. Otherwise, our else case, we're going to turn the speaker off and make sure it's off. Okay, and this is controlling the speaker, so we call that function every time through the loop, and pass to it the current sound. It's going to take that current sound, and it's going to check to see, and so this is going to get confusing because we have the same variable name here, but it means different in this context. And it's going to check to see if that sound that we're passing in, which is our new sound, this should be new sound though. Let me change this. There we go. If our new sound is something other than none, because that's what we set it to when we're not doing anything, then and we're done playing our current sound, then we are going to go ahead and switch that sound. And what that means also is that if we pass in a new sound to play, but we're in the middle of playing a sound currently, it won't play the new sound. It'll just finish the one that it's doing. And so, like if it's moving, and then you play like the eat sound or something, because it's longer, you're going to get some movement sounds that don't occur because it's in the middle of playing the other sound. Okay, and so that's how that play sound function is working. The next thing we're going to do the switch sound. And so let's go ahead and implement that switch sound function right here. Okay. Okay, so here's our switch sound function. So we pass in the new sound, and we're going to assign to our current sounds array the whatever index. So remember, this is indexed to the sound, and so our tones array has the eat tones and the move tones, and so we're going to pass in for now a 0 or a 1 to pull up one of these guys, and do the same thing with the delays. And so it's taking the array right here or right here, and it's storing it into this current sounds and current delays variable. And then it's also going to get the current length from our lengths array right there. So it's taking from each of these, it's getting the current sound. Okay, and then we're going to turn our buzzer to on. We're going to set the speaker to on. We're going to reset our sound timer. We're going to set the delay, our first delay of the sound timer, based on our new current delays array. And then we're going to update our current sound variable to say that the new sound that we just passed in is going to be the sound that we're playing now. And then we set our current note to 0. And so what this does is, when we come back around to this function again, the current sound is no longer none because we just switched it to the new sound. And so we skip this if, and then we say, and because it's not none, we're going to call the speaker control function. If it was set to none, we would call this one right here, and nothing would happen, no sounds would play. Finally, we are going to implement our speaker control function now. So I'll put this one down at the bottom. Okay. Okay, and so here's our speaker control function. This is kind of the biggest one, and so we have kind of two cases. So we have the if the buzzer state is on, and then the else case when the buzzer state isn't on. So we're going to come through here, and we're going to check to see if the buzzer is currently on or if it's off. And so we're going to have a little pause between the notes so that we can have like a little bit of emphasis in between those notes. And so we have that on state where it's playing the note, and then the else case where it's that brief pause. Then we're going to check to see if we've played the whole sound, and if we have, we reset that current note value, set the current sound to none, and turn the speaker off. Okay, so coming up to here, in the case that the buzzer is on, we're going to check to see if our time's up, and until the time's up, we're going to play the current sound. And then when the time's up, we come to here, we set the buzzer state to off, We're going to reset our sound timer. We're going to set a short delay, change the delay to be just this brief little pause, and then we're going to increment the current note. In the else case, we're going to turn the speaker off, and then we have our new timer started, and we're going to wait till that 20 milliseconds has passed, and then we're going to reset our timer. We're going to select the delay to the next note in our array, and we're going to set the buzzer state back to on. And so it's going to basically, every time it calls this function, it's going to switch back between the on case and the off case, or at least like it's going to, as it calls it, it's going to switch back and forth between those until the sound has fully played. And then when it's done, when we've played all the notes in the sound, we're going to set that current sound to be none and turn the speaker back to off. So this one, there's kind of a lot going on here, and certainly might be kind of confusing, but this is kind of the meat of our controlling the sound. There's probably a simpler way to do it, but this was kind of the most intuitive way for me. And the reason this is so complicated is because we want to be able to control these speakers without putting in a delay, which would cause the game to pause. Okay. Now there are actually more advanced ways to do this, and like instead of having to operate like this timing stuff all on our own, we could use what's called like an operating system, and the microcontrollers are capable of running multiple threads at the same time using an operating system. And so as games might get really complex, instead of having to keep track of all these timer events and stuff and have these timer objects, we can let the operating system do that work for us, and we can just make the threads ourselves and let the operating system manage the things happening in between. Okay, so this is our sounds though. We'll go ahead and play it and hear the sounds come on, and then you can kind of come up here and mess around with the notes for each of these sounds. Just if you change anything, make sure to change the corresponding links down here, and so on. Okay.